Hello there and welcome to this series of videos going through the content of A-Level Further Maths. Here we're looking at how we would summate squares and cubes so we can answer questions from exercise 3b. So previously we saw that there was a formula that we could use to summate all of the integer values. Now we're going to look at a formula for summating this integer square values and the integer cube values as well. So the formula to add up a whole bunch of square numbers, so 1 squared plus 2 squared plus 3 squared plus 4 squared, or in other words 1 plus 4 plus 9 plus 16 plus 25, etc., etc., is given by this formula here. You can use either formula n plus 1, 2n plus 1, all over 6 this time, or it could be thought of as just bringing the sixth to the front. And the formula for the cubes looks very similar to the formula for the normal integer values, just everything's been squared, n squared, n plus 1 squared, and 4 on the bottom. Or the 4 could be factorised out to the front. So now we've got to remember two more formulas, but in fact these two formulas here are given in the formula booklet that you get in an exam. You need to remember these though. Okay, they're not given to you in the formula booklet. Proofs of these will be given in chapter 8. So, first of all, let's keep it nice and basic to start with. Sum up the first 30 square numbers, 1 squared plus 2 squared plus 3 squared plus 4 squared, all the way up to 30 squared. And a much easier way of doing this is to just substitute in 30 into your formula. So substitute in 30, so that's 30 times 31 plus 61 times 61 all over 6, and the final answer to that will be 9,455. So that's what you get if you add up 1 squared, 2 squared, 3 squared, all the way up to 29 squared, add 30 squared. Okay, so it's just a simple use of using the formula. The formulas sometimes with summations that they ask you to do don't always start at 1, unfortunately, but we've got a method for dealing with that. What we do instead is we use our formula to substitute from 1 up to 40 of the first cubed numbers, and then we take away, because we're adding up too much here effectively, we want to now subtract the first 19 cubed numbers, so we're just left with then the 20th up to the 40th cubed values. And now that our formulas or our summations start at 1, we can now use the formulas that we've been given to use. So substitute in the values of 40 and 19, calculate these, and we get 636,300. Okay. So it's not too bad. Just make sure that when you see that your summation doesn't start at 1, that you make sure you do a little bit of an adjustment. And remember that 19 that was here is always going to be 1 less than the 20 that we have here. Right, okay, so this is more of a challenging problem here. We're not starting at 1. We're not even going from number to number, we're going from n plus 1 up to 2n of r squared. So, what we're going to do then is, in a very similar way to what we did before, we're going to have to use the summation formulas from 1 up to 2n or 1 up to n. We're going to have to do a little bit of subtraction here. Now the first term is going to be from 1 up to 2n. But remember then the amounts that we subtract is always going to be 1 less than what we get here. Previously it was 20 and we subtracted on the top 19. Now we're going to subtract n, 1 less than n plus 1. Okay, so now we've got the summation of the square numbers from 1 up to 2n. And we've got take away the summation of the square numbers up to n. So, write down the formulas, but now for the first one we're going to substitute in 2n to everywhere that there is an n. And for the second part of this expression here, we're just going to keep n as it is, because we're just substituting in n effectively. So it's 2n times 2n plus 1 times 4n plus 1, because 2 times 2n is 4n plus 1 over 6, and subtract the same formula again because we're just substituting in n. Now, we don't really want to leave our final answer like this. That wouldn't look particularly nice. So what we're going to do is a bit of factorization. So we can clearly see here that there's a sixth as a common factor in everything that we've got here. We can also see that in both of our terms we've got n here, it's underlined in blue, and here. We can also see we've got 2n plus 1 that is in both our terms here. So we'll factorize out 2n plus 1 from both of the terms. Now what we need is a big set of brackets to include everything else that we didn't use in our factorization. Now at the start here we've got a 2 and a 4n plus 1 that we didn't include in our factorization. And then it subtracts n plus 1 that we didn't use in our factorization. You can see here that if you were to expand the brackets, you'd get to the line above. So we've just done quite a big factorization step from this line here to this line here. This step here needs a bit of practice, so it's really important that once you finish watching this video, you go back and you practice a lot on these types of questions. But now all we need to do is simplify what's inside that square bracket. Make sure you subtract everything in the second bracket, and that's your answer. Okay, n, 2n plus 1, 7n plus 1, all over 6. So the factorizing step is crucial here, otherwise you'll end up with a cubic and you'll try and factorize the cubic. So I wouldn't advise expanding at this step here. If you try and expand at this step here, you're going to be there forever and it's going to be very difficult for you. Alright, so using this formula here, let's just check that our formula is correct for n equals 1. So substituting in 1 into our formula here, we get 4. And substituting in 1 into our formula here, we get 4. Substituting in 2, very similarly, we'll get a summation from 3 up to 4. So that's 9 plus 16 is 25. And substituting in 2 into the formula, we're going to get 25 as well. Substituting in the value 3, we're going to get a summation from 4 up to 6. That's 4 squared plus 5 squared plus 6 squared. We get 77. And substituting in 3 into our formula here, we're going to get 77 as well. Alright, so a little bit more of a challenging one here then. So show that the summation from 1 up to n of r squared plus r minus 2 is equal to n over 3, n plus 4, n minus 1. So this is effectively substituting in 1 into this expression, find the answer. Substitute 2 into this expression, find the answer and add it on. Substituting 3 into this expression here, so you'll need to square it and then add it on to itself and take away 2. Keep on doing that up and up and up until n, and you'll get this formula here. Now the first thing you do with summation questions is you split them up. You split them up into separate series that you can compute or you've got a formula for. So we've got a summation formula for r squared, we've got a summation formula for r, we've got a summation for the sum of ones, and we'll just factor out a 2 from there. Now we use our formulas. So we've got the first formula for the r squared series, we've got our second formula for the r series, and we've got our third formula for the 1 series, which is effectively just a bunch of 1s added up together. So that's just n, and we've got to obviously times it by 2. Don't forget you've got to subtract this part here, but we're adding this part here. So now we've got to simplify this, and the best way to simplify this to start with is by creating a common denominator in all of our terms. So we've obviously got a sixth here. Common denominator will be a sixth. So we've got a 2 on the bottom here, so we need to times top and bottom by 3 on this case here. And we need to times top and bottom by 6 here, so we'll get minus 12n over 6. All of these expressions from one line to the other are all equal. We've just created a common denominator of 6. So now we're going to try a bit of factorizing, and this is the difficult step. And it's the step that people always struggle on. So, factorizing out of 6 from all of our expressions is nice and easy. Now we've got to look through 3 terms and look for common factors in all 3 terms. The only common factor I can see here is they've all got n in them. N is here, n is a factor here, n is a factor here, and n is a factor here. So in this case here, that's the only thing I can see that we can factorize. Now we need to look at what we've got left over. We've got n plus 1 to n plus 1. In the second bracket here, we've got 3 bracket n plus 1. And in the last section here, we've got minus 12. Okay, so that really there is the difficult step in these sorts of questions here, where you've got to do some factorizing with a lot of terms. Right, let's now sort out what we get inside the big squared bracket. Expand, factorize together. Now what we notice here is that all of the terms above inside this bracket here are all even. They've all got a common factor of 2. So I'm expecting that we could pull out a factor of 2 to the front of the bracket here, and we can simplify our fraction here. Let's continue over here. So we can cancel out our fraction with a common factor of 2. So we've got an over 3, and we're nearly there. We've got an n and a 3, and it looks like maybe we might be able to factorize this quadratic inside the brackets here. So it's n plus 4, n minus 1, and that's exactly what we want to show. Perfect, great. So quite a long question here, quite a lot of algebra, and you're gonna get to need to get used to this. The further maths will involve a lot of algebra, pages of algebra sometimes. So we're gonna have to practice this and get comfortable with it. Great. So we've got a final answer there. So how can we add up all of these terms here? Well, we must obviously assume we start at 1 here. 1 squared is 1, plus another 1 is 1. Take away 2 is 0. No, we may not start at 1, or we could effectively think of this as 0 plus. Let's start at 2 now. So 2 squared is 4, add 2 is 6, minus 2 gets back to 4. Great. So this term here is going to start at 2, and then we'll continue going upwards until we get, now because this 0 here doesn't really affect the series, we can think of this as starting at r equals 1, because effectively we're not going to add on anything here. We need to know how high we're going to add up to, or what number we need to substitute in to get 418, which is the last term that will be summated. So what we need is r squared plus r minus 2 to equal 418. So from doing a little bit of solving quadratic equations, we know that r is either equal to 20 or minus 21. Now, given that it's not going to be a negative number, it must be a positive number, so r must be 20. So the term or the value that's going to appear on the top of our series is 20. We've worked that out algebraically. And now all we need to do is substitute 20 into the formula that we worked out effectively in part A of this question. So 20 substituted in, 20 divided by 3 times 24 times 19 will give us 3040, which is going to be the same as this expression here. Alright, let's have a go at maybe one more that involves a cubed this time. So this time we want to find a formula for this series here. The series involves substituting in a lot of numbers into the expression of r times r plus 3 times 2r minus 1. Now remember, when we're doing these sorts of summations, the first thing we're going to really want to do is split them up. Now we can't split them up with a multiplication. We can't do the sum of r times the sum of r plus 3 times the sum of 2r minus 1. We're going to have to substitute the brackets first. So we've got an equivalent expression here. And then split the series up and factorize the numbers that appear at the front of the r's. So we're going to split this series up into 2 times the summation of r cubed plus 5 times the summation of squared numbers, take away 3 times the summation of just normal numbers. Now what we can do once we've split up our series into 3 separate components is we can now use the formulas for the cubed series, the squared series and the normal numbers series. So for this cubed series, remember it's 2 from the 2 here, that still plops in, is n squared n plus 1 squared over 4 plus 5 will still come in from the 5 that's factorised at the front, n plus 1, 2n plus 1 all over 6, minus 3 from the 3 up here, don't forget to include these values, n plus 1 all over 2. And now what we've got to do is group together all of these 3 pieces of algebra in a very clever way such that it will simplify the algebra. The first thing we're going to do is look for a common denominator on all of the denominators. So 4, 6 and 2. The lowest common denominator I can think of here is 12. So for the first... Okay, we could think of it as 6 as well. I suppose we've got 2 over 4 here, so that effectively could simplify to a half, and then it's just the same as 3 6. That's a bit of a clever way of doing it. Sneaky PowerPoint that I'm using. Alright, so we're going to use sixths instead. So it's 3n squared times n plus 1 squared all over 6. Add 5n n plus 1, 2n plus 1 all over 6, minus 9n times n plus 1 all over 6 as well. So we've times the top and bottom of this one by 3, kept this one the same, and times the top and bottom of this one we've cancelled out 2, and then we've times by 3 afterwards. So now let's group all of this stuff together and put it all over 6. Now comes the difficult part. Now comes the part where we have to factorise from 3 expressions as much as we can. Now, from glancing through all these 3 expressions here, I can see they've all got an n as a factor in all of them. The last 2 have just got 1n. This one's got 2 n's effectively as a factor. So we've got an n that we can factorise out. We've also got an n plus 1 in all 3 of these terms here. We've got an n plus 1 here, an n plus 1 here, and an n plus 1 here. We've got 2 of them, so we'll just pull out one of these factors of n plus 1 here. So we're factorising out n plus 1. Always try and factorise out as much as you can. That way it's going to help later on from when you've got to factorise it back down. Now we look at what we've got left over. We've got 3 in the first term here. We've also got another n because n squared is effectively n times n. And we've also got another n plus 1 because we've only pulled out one of these as a factor. So it's 3n n plus 1. On the second term here we've got 2n plus 1. And on the last term here we've got negative 9 because we've pulled out everything else. Let's now group together everything we have inside that squared bracket and simplify it all together. And it looks something like this. Our final answer is n plus 1, 3n squared plus 13n minus 4 all over 6. Okay, so that's quite a tricky formula there. So part B of this question here is hence calculate the following. the summation from 11 up to 40 of this sequence here. That's the same as this sequence here, so we should be able to use the formula here. It's going from 11 up to 40, so what we'll have to is use the series formula from 1 up to 40, but then subtract the series from 1 up to 10. Remember, the 10 here is always going to be 1 less than where we want to start our summation from. Substitute these values 40 and 10 into our formula and calculate, and we get 1,445,230. Alright then, so that's the answer to this question here. Very long question here, but it's really typical actually. You're bound to get a question either similar to this in the exam, so make sure you've had lots of practice at these types of questions. You do get the squared formula and the cubed formula in the formula booklet, so you don't need to memorise those two, just have them to hand so you know what they are. Alright then, so here we are. So have a go at these two questions here, then pause the video and come back afterwards to see if you've got it right. Okay, so the first one here, question 2a, is quite a simple one really. All we need to do is substitute 2n into the r squared formula and show that it equals this. So remember the r squared formula is equal to 1/6 n plus 1 2n plus 1. So and that goes from r equals 1 up to n. So if our series now goes up from 1 up to 2n, effectively all we have to do is double all the n's in this formula here. So it's 1/6, 2n, 2n plus 1, 4n plus 1. Because we're doubling the n's each time. Okay, it's not quite how we've got our final answer here. We just need to now cancel down the 2 and the 6 here. So now it's just 1/3 n, 2n plus 1, 4n plus 1. So that question there was pretty easy, to be fair. The second question here is a little bit more tricky. The first thing I would do on this one here, and I'd always recommend it, is to expand the brackets. R squared plus 7r plus 10. So now we're going to summate this series here, and the first thing I would do next is to split them up into separate series. So I've got the series for r squared, series for the summation from 1 up to n of r, and then 10 summating lots of 1's up together. So in this sequence here, I'm going to have the first formula substituting in for the series of r squareds, which is going to be 1/6 of n plus 1, 2n plus 1. Then it's going to be add 7 lots of n over 2 n plus 1. And then in the third part of the formula here, it's just going to be 10 times the formula from 1 up to n of adding a bunch of 1's up. So that's just 10n. Now next what I'll do is I'll create some common denominators. So I think 1/6 is going to be able to be a denominator of all of these terms here. On the second term here, I need to times top and bottom by 3 to get a 6 on the bottom. So this is going to be 21n, n plus 1. And on the bottom of this one here, it's going to be 60n over 6. So now comes the factorizing part. I've got a 6th as a factor on all three terms. I've got n as a factor on all three terms, and that's it. So now what I've got left is n plus 1, 2n plus 1, plus 21. The n has been factorised, the 6th has been factorised, so I've just got n plus 1 left. And on the final term here, the 6 has been factorised, the n has been factorised, so I've only got 60 left in that final section there. Now we just need to sort out what we have left inside this square bracket here. So I've got 2n squared. I'll have 3n plus another 21n, so I'll have 24n. And I'll have 1 plus 21, that's 22, plus 60, so that'll be 82. All of these terms here are even. Yeah, that's good. So I'll factorise out 2/6 of n squared plus 12n plus 41. Yeah, there we are. This is getting to work now, isn't it? So final answer here is to now cancel out the 2 and the 6. So it's a third n brackets n squared plus 12n plus 41. There we are. Perfect. Great, so that's how we show that the summation of r plus 2 times r plus 5 summated from 1 up to n is equal to that big long formula there. So that's the end of the second video, and it's the end of the chapter as well. So it's a quick chapter, but it doesn't mean you don't need lots of practice at it. You need tons of practice. I would actually recommend doing all the questions in this exercise to make sure that you've got it absolutely nailed. So these types of questions here are long. Make sure you don't trip up halfway through. That's a common mistake to make. Classic techniques to use are to split up your summations so you can split up the formulas. Create common denominators on all of your algebraic expressions so that it's then easier to factorize. Look for common factors in all three terms. Sometimes the n plus 1 will be a factor. In this case it wasn't on the third one, so we couldn't pull it out from all of them. And yeah, make sure you have lots of practice, everyone. Okay, thanks very much for watching.